Okay, cool. Great to see so many faces in the crowd. We're just going to do a quick round of introductions. So my name's Melody. I'm a software engineer at Cresicor, and I actually took Web Lab as a student back at MIT with Nick, who's one of your staff members. So that was kind of my first foray into web development, which ultimately led me to what I do at Cresicor. And here we have Daniel, who is our CTO at Cresicor, and he'll be doing most of the lecture. So I'll pass it off to you.
All right, hey everyone. So as Melody mentioned, I'm one of the co-founders and the CTO of Cresicor. So I started working on this as an undergrad, specifically a sophomore, right here at MIT. So it's been, probably 4 years, though it feels much longer than that. So I wanted to share with you guys some of the lessons that I've learned and some of the things that we've done at Cresicor that MIT really didn't get a chance to teach me through any of the courses. And some of you through your careers as a student will probably learn that there are some things that you just can't learn in university courses. And one of them is that a lot of your time, if you join like a software engineering job or anything like that, is going to be spent in meetings, right? Not necessarily writing code. You will have a lot of time spent in meetings, okay? So one of the lessons I've learned is that everyone should come prepared to every meeting with an agenda and ideally a goal for what they want out of the meeting, okay? Because otherwise, a lot of meetings will be unproductive, right? And with that, here is today's agenda, all right? So what does Cresicor do? What do we do at the company? What problems have we solved recently? And how do the problems we've solved relate to web development, both in the context of this course that y'all are taking right now and beyond, okay? And if you have any questions, you can raise your hand at any point. I'll also stop. What's up? Oh, this window here? Oh, it is? Oh, okay. Is that better? Cool. All right. If you have any questions, feel free to raise your hand, or if you're watching virtually in the Zoom chat would be great as well. Okay. So first question you might all have is, what do we do as a company? You may or may not have heard of us, depending on who you are. But in order to illustrate this most effectively, I'm going to need some audience participation. All right. So can I have everyone in this room stand up? And if you're watching virtually, you can stand up too, or pretend to stand up, whatever floats your boat. All right. Cool. Everyone is standing. Some of you are carrying laptops, but that's okay. Cool. So what I'm going to do in this exercise is I'm going to start showing the names of companies. Okay, these companies manufacture food and drinks. All right. If you've heard of the company before, maybe you've seen it in a television ad, maybe you've seen it at a grocery store, maybe you've seen it, at a very unexpected place. But if you've ever seen or heard of it before, I want you to sit down. All right, is that clear? Cool. Let's start off with Perfect Snacks. Maybe you've seen it at like Trader Joe's or Starbucks or something. All right, a few of you, but not that many of you. What about Oatly? Maybe you've tried it at, maybe you've gotten oat milk at a, I don't know, cafe or something. What's up? Or, oh yeah, they've been on the Super Bowl or like they're an ad for the Super Bowl or something. All right, well, still some of you. Amy's, maybe you've tried their frozen enchiladas or something like that, or frozen like pad thai, no? All right, so some of you sat down, but not a lot of you. What about Lesser Evil? Maybe you've tried their like popcorn or something. Okay, I think 0 people sat down. Uncle Matt's. Okay, I think 0 people sat down again. Maybe the people that are still standing just don't try anything. And I buy that. That's fine. Hint Water. Okay, some of you sat down. Some of you sat down there. Okay, but I think probably like 10% of you are still standing. That's fine. Wild Planet. Or okay, at this point I've given up hope. Barnana. No. Okay. Anyway, for those of you still standing, all right, I have some homework. Okay, try one of these brands. They're pretty good. All right, you can sit down. Thanks. Thank you for participating in this interactive activity. You might be wondering, what do these brands have in common? And why is there so much empty space on the slide? Well, these are all customers of Cresicor. And we have, a lot more customers, which is why there's so much empty space. But the punchline is, right, all of these brands, and why I mentioned television ads, why I mentioned, grocery stores, whatever, okay, all of these brands run hundreds or even thousands of discounts and ads each year, right? You might have seen them at television, on the TV. You might have seen them at grocery stores, like buy one get one off, buy one get one free, 20% off, things like that, right? However, okay, this is the most important part. Most of them are tracked in spreadsheets, okay? So a lot of these brands, what they do is they track, a bunch of info about every deal that they run in a spreadsheet. And like, this is probably what you've, done in the past, with your final projects or your final papers or your, and like I'm guilty of this, like my report, final V2 fix part 5, stuff like that. This is literally what professional people do in their jobs, okay? Which makes you wonder why? Like, why is it that people that are twice our age are still doing this, okay? And like, here's some of the metrics people track, right? Like how many products are gonna be on discount, by how much should they be discounted, et cetera, et cetera. The smart way to do this is to build a web platform, right? That's what this class is about, building web platforms. The smart way to do it is to build a web platform like Cresicor. Okay. So obviously, I can't cover all the problems these brands face in one lecture, right? That would be way too hard. And today's lecture is going to focus on, a small subset, a very small slice of what these brands do. Okay. And I'm going to focus on one particular problem these brands face and one particular thing they do. All right. So today's lecture is going to focus on forecasting. Okay. Predicting a brand's future business. Okay. And what do I mean by that? So let's do a case study. All right. Today, I'm going to open a new company. I'm going to open a company called Daniel's Delicious Flavored Chocolate. All right. So my company makes 3 flavors of chocolate. Okay. Strawberry, mixed berry, and banana chocolate. Okay. And we do business with 2 grocery stores, Walmart and Target. Okay. So let's make a table of how many items we sold this week. Okay. So this week, which is January 10th to 16th of 2022, here's a table of how much we sold to each grocery store of each type of chocolate. Okay. So I sold 50 items of strawberry chocolate. And like this could be, individual bars. This could be like cases, right? A lot of these brands do their business in cases. So like one case of strawberry chocolate could contain like, 100 bars or 1,000 bars or 10,000 bars, right? So 50 units of strawberry chocolate were sold to Walmart. 50 units of mixed berry chocolate were sold to Walmart, so on and so forth. Okay, any questions about this? I think it's pretty straightforward, right? Okay. Suppose that next week, we predict that we'll sell 5 more of each type of bar or each type of item or case or whatever to each grocery store, right? So the table for next week, which is January 17th to 23rd, is going to look like this. 55, 55, 55 on top, and 105, 105, 105 on bottom. Okay, make sense? Cool. So you can kind of imagine, right, that the data in this case study is kind of like 3-dimensional, right? So we have a 2-dimensional table for every week. So if you imagine that we have like, 50, 100, 150 weeks, like 50 weeks is about a year, right? 50, 100, 150 weeks. It'll look very 3-dimensional. You'll have like a table for every week, and you can imagine like a depth dimension, right? Like the table and a second table and a third table and so on. Okay. So my question to you, okay, say you were writing a web application to like represent this data or store this data, you would need to store all of this data for every week in a database, right? How would you store this data in a database? And this is the first question I'll ask that I'll throw people balls if they give suggestions, okay? So think about this for about a minute by yourself or so, and then I'll have you guys like talk amongst yourselves for another minute or so, and then I'll ask for people's suggestions. So think about how you might store this in the database. Actually, why don't we start talking to each other? I think the quietness is driving me a bit crazy. Kind of like this. I don't know. I'm bad at drawing. Any suggestions from anyone? How might we represent this data? Yes. I like that idea. Oh, sorry, that completely missed. Sorry. Anyone else? No? No one else wants one of these?
I'll store it on the blockchain, and then I'll have a I'll have a single string that represents everything, and then you have a manually parse it.
All right, let's have a vote. Is that worthy of this?
Yeah.
Yes? All right. Anyone else? Yeah, go do that. Cool. So I think those are all great ideas. So I've heard some suggestions, for example, about using tables or like Excel sheets or things akin to Excel sheets. I've heard some suggestions about using like a dictionary with keys and values. And I've heard some other creative suggestions, such as like storing just the deltas between, like different weeks, and a couple of, slightly outlandish, but maybe doable in a few years suggestions like blockchain. But I'm not sure if we'll get to that today. Let's see. So I'm going to talk you guys through this problem and how we thought about it as a team. Okay, so I'm going to go through in kind of chronological order the approaches that we took to solving this problem and storing the data. Okay, and out of this is going to come a lesson. Okay, but that's at the very end. So let's talk about our first approach to storing the data, which is kind of what was suggested in terms of the dictionary. So here's an example representation of the data in JSON. Okay, and JSON stands for JavaScript Object Notation, which some of you may be familiar with. But essentially what it is just a dictionary of data, right? So here's an example. Okay, So here we're storing the data by product, by the type of bar, then by the grocery store, and then by the week. So it's kind of like, three-dimensional data just stored inside a dictionary. Okay. Now, let's put on our thinking caps for a little bit. Okay. So consider the following. In this example, right, we only have 2 grocery stores, we have 3 products, we have 2 weeks, and we have 1 metric. We're only focused on the number of items we sell. Okay, but consider this, right? In the real world, we deal with a lot more data. Okay, we deal with 300 or more grocery stores. Every customer we work with has something like hundreds of grocery stores they ship product to. They also have hundreds of products, right? It's not just about, strawberry or banana chocolate bars. They have so many things that they produce and they make money with. Okay, they have to consider data over years, right? Hundreds or more of weeks. Okay, and they're not only worried about the number of units they sell, they have to worry about many other things in order to make sure their business gets the most bang for their buck, right? So 10 or more metrics. So as you can see here, the total number of data points these companies need to deal with can get into the hundreds of millions or the billions, right? It's not going to be as clear cut. Like the first approach you're going to think of is definitely not going to be the best one to store the data, right? And that was the case for us, right? Like the first thing we thought of, which is storing the data in a JSON format in the most kind of brute force manner, is not going to be the best one. Okay. So how do we improve the performance of this data? So as you can see here, there might be some inefficiencies in how we're storing this data, and there definitely are, which is why the talk hasn't ended yet. But any suggestions? And talk to your neighbors, and there might be some of these. Yeah. Any other suggestions? How can we improve the performance of this data? Let's give everyone some time to talk to each other, maybe a minute or so. Okay, any other suggestions? Yeah, maybe. Have another one. Oh no. So you're saying, like, instead of just accessing it, take the difference of 2 of them. I still have a lot more of these guys. So you're suggesting like storing, instead of like having the grocery stores be separate, storing them all together in a single object. Okay. Oh, sorry, that kind of missed.
3 numpy. Hope your server has a lot of-
Yeah, I mean, if we were a Series D company, then that might be doable. There you go. I'll talk to you in about 4 years. Cool. So these are all good suggestions. So I think I got a few suggestions along the lines of using different like data structures or trying to reduce the number of times that we repeat these really long keys, right? Because you can see here things like strawberry or mixed berry or banana don't need to be spelled out every single time, right? That is very inefficient, right? So I got some suggestions about using arrays or using, data frames, things like that, so that, we can store the keys as columns or just as integers instead of the dates being, stored every time. So here's an example of what we might do, right? We can reduce the length of the keys. We can change the dates to integers, right? And we can have, separate dictionaries mapping the keys to the actual values, right? So that if we wanted to display the data on the front end, we could, just reference those dictionaries instead of having to, store the keys every time, which I think is pretty good. And it actually gets the data down a lot. So the current size of data, how many bytes are in this? Well, it's 138 bytes. So now, how do we make a more fundamental change to how we're storing this data to make it not only smaller, but also making a web application that uses this data more performant? Okay, just to give you guys a sense of what you need to think about when you're, considering the implications of how much money you're spending to maintain a web application, right? There's not only server costs, there's also how many times you need to, perform API calls or also developer costs. If you're running an actual business, you need to think about how much time your engineers are spending writing code. If you can make it any easier for them to write code, you'll be saving a lot of money, right? So how do we make it not only smaller and more performant, but also easier to enforce data constraints and things like that? And that is the point of this talk. Okay, I'm going to talk about SQL versus NoSQL databases. All right, and I think I've heard some keywords thrown around by people like relational databases, as well as trees and data frames. Okay, so that's what the crux of the problem that we were facing and the problem that we took a different approach to. Okay, very recently, actually, I think over the course of the last 2 months or so. So this is still very fresh. So just to give you guys a definition, for those of you who are less familiar with these concepts, here are some definitions of what a SQL and what a NoSQL database is. Okay, so MongoDB, okay, the database that some of you might have heard of by now, is an example of a NoSQL database. Okay, the main types of NoSQL databases, and this is from the Mongo documentation online, are document key values, so things like JSON, wide column, and graph. So you can imagine a tree structure or a key value structure, things like that, or a text glob even, right? And they provide flexible schemas, so you can write whatever data you want in there. It's not going to be as rigid, and scale easily with large amounts of data and high user loads. Now, an example of a relational database is PostgreSQL, or just Postgres for short. Okay, this is a database where things are mainly stored in a two-dimensional format. Okay, it's like a data frame for those of you who use Python or Pandas or NumPy, right? Its data is stored in two-dimensional tables consisting of data rows and strictly enforced column types. So it's very easy to enforce the structure and the types of data that are stored in a relational database. So you can say, this column has to be an integer. And as soon as you try to write data that doesn't follow those constraints, it tosses an error at you. And Mongo is going to be a lot more lenient about what data you can store in there. So if you write something garbage into Mongo, it spits out garbage, and your website's probably going to crash with an unhelpful error message. But anyway, one disclaimer I wanted to give you guys, okay, is that in this class, you are recommended to use MongoDB, and in the real world, you'll have the freedom to choose whatever database you want, okay? But like my purpose here is not to, shame one database or like plug another one, right? It's to give you guys context on how we solved our database problem, or like, I guess, thought about it with our specific use case in mind, right? So a lot of you are going to have your own, website ideas, et cetera, et cetera. And some of you might, start your own companies in the future or like have your own startup ideas. But the purpose of why I'm talking to you is just to give you our perspective on what we did and how we thought about our problem. Okay. So how might you represent this data in a relational database? And to give you guys some more context on how you might answer this question, right? We have two tables here, right? We have two-dimensional tables here. And the goal, our goal at least, if we want to store this in a relational database, it would be to combine the two tables into one single table that stores all of the data. Okay, so how might you do that? Oh, sorry, that missed. Any other suggestions? Yeah. Oh, sorry. Back rows are hard. Any other ideas? Going once, going twice. Cool. I think those are both good ideas. I think I wanted to talk about some potential things we considered because we considered both of those suggestions, right? Like we considered having the week be a separate column. For example, like it would look very similar to how it is organized right now, but we would have the grocery stores be one column, the products be another column, the weeks be another column, and the metrics be another column. That's something that we considered. We also thought about the idea of just having one table and having each cell be an array, right? But there's kind of a both like approaches have their own pros and cons, right? And I'm kind of being a little unfair by not this is a very watered down, I must say, right? Like version of the real world problem, and doesn't really give you guys all the context into what these brands actually face. So I'm gonna tell you guys what we chose based on outside information we had about the space and the business logic. Okay, so what we did was we decided to have the first approach of one column for every type of data. So like the customer, the product, right? Or the grocery store, the product, the week, and the metrics. And that's because we kind of decided that beforehand, right? We had the schema or the format of the data fixed. Okay, so we likely weren't going to add more fields or more columns or anything like that. And the other thing was if we took the array approach, right, it would be a little more difficult to change the columns or the format of the table, right? Because if we had the rows and columns being, I guess, like product keys or grocery store keys, like that would make it, less SQL-like, right? Because then the rows wouldn't be individual data records. They would be rather like customer or product records, Okay, I hope that makes sense. I think that was confusing. But the bottom line is like, there is some outside information we had to use about our customers and about what they face in order to decide on the best approach. Okay, so here's what I mean by that. Okay, we have the grocery store, the flavor, the week, and the metric, in this case, the amount of sales, as separate columns. So here's how we decided to store the data. Okay, and as you can imagine, if we had 10 other metrics on the right, then there would be a bunch more columns, right? But here is the data in the format that I have described to you all so far. Okay, are there any questions about this? Yeah. Oh. Any other questions? Oop. No questions. Okay. So what is the size of this data? Well, it's 115 bytes. But what you guys might think, right, is that 115 isn't a big improvement over what we had before, right? 138 was what we had before. And this is basically just taking out the braces and the commas and the spaces, right? This is really just like putting the grocery store keys, the flavor keys and the week keys and the sales values in a table, right? You might think, right, that this isn't a big saving, but there are a couple other outside factors, as I mentioned. So like, remember when I talked about spreadsheets, right? This screen, by the way, is like what many people at these companies face. This is probably something you guys have seen when you were very little or haven't seen it all. But the data is inherently tabular, right? The data that these companies use is often in Excel. It's often like row by column. There's often metrics on the row, on the columns, and each row is a separate data point, right? So if the data is inherently tabular, why would you use not a table to store them, right? If you use anything other than a table to store the data, like a JSON object, you would need to convert back and forth every time, which is a very expensive operation. Okay, it takes on the order of minutes to convert like 100 million rows of data from a JSON object to a data frame and back and forth. And this is the problem we faced, right? Every time we had to deal with data that was in a JSON object format, we would need to do effectively like a triple for loop on that data. And for loops are really slow, okay? So another thing about the tabular data is that the code was harder to write, okay? And if you have code that's hard to write, that is going to eat up a lot of developer time. And developer time is really expensive, okay? Like, I think developers, make a lot of money. I don't think it's bad for me to say that. And if like developer time is the most, like the biggest resource you're consuming, then that's a problem, okay? So another thing is that the schema or the format of the data is easier to enforce in a relational database. If we were to store the data in a NoSQL format, as I mentioned earlier, it would have been harder to enforce no writing of arbitrary data, right? Because like as I said, in Mongo or in any other NoSQL database, if you wrote arbitrary data to the data store, it would, it would just let you and like not throw an error at you and the website would crash, right? So in this case, like the schema is basically easier to enforce in a relational database. It's easier to have the database throw an error at you if you try to write invalid data. So we actually migrated, right? From NoSQL to SQL data, from a JSON format to a tabular format. So previously, we used Firebase to store all customer forecasting data, okay? Think about a worse version of Mongo, okay? Like a worse version of Mongo with no types, with a lot fewer features, okay? we used Firebase, and now we switched to Postgres. And customers with more than 100 million data points saw a 10 to 15x improvement in speed, because there was no more need to transform things back and forth. There was no more triple for loops or quadruple for loops, right? And also, we were using fewer developer resources, right? The code got easier to write. People had to, read and review shorter pull requests, et cetera, et cetera. So this was overall a very big win for both our customers and for us as a business. Okay. So the moral of the story is, when designing an application, always consider the pros and cons of how you store data. And here are some extra reading materials if any of you are interested in exploring further. So I must also say the obligatory thing, and if this talk piqued your interest, we love to chat about potential opportunities. So we are hiring for both full-time and internship roles. Check out our careers website if this sounds interesting. And thank you all very much. And we'd love to take any questions. And I still have a lot of these to give away. So yeah.
Sounds like your data was already in the sweet spot of what a relational database is good for. What led you to looking at Firebase or other technologies in the first place?
That's a great question. So a bit more context about how we grew as a company. So as I mentioned, I started working on this in my sophomore year along with my brother, Alex. We used Firebase because it was cheap and easy to use, right? And this was before we had our first customer. This is before we even thought about this problem, right? And it's often the case that, right, like you guys go with like whatever fits your budget at the time, right? If you're like a small company with no revenue yet and you're putting volunteer hours into the project. And this problem really didn't come up until very late into our development cycle, right? Like we were on Firebase, it was working for us, it was solving all our problems at the time. But it's often the case, right, that like as you grow, as you try to scale, this like the first tool you use doesn't really fit your needs anymore, right? And like that was the case for us. Sorry, that completely missed.
Quick question, what's your name?
Oh, yeah.
Yeah, we said
Question.
Some data you wanted to store, and it was unclear whether SQL or NoSQL was present.
Let's see. So I'm going to give like a kind of sideways answer to that question. I think some of our data is better for NoSQL, some of it's better for SQL. So in this particular example, this like forecasting example, right? Like all of the like sales data, all of the data that I presented in that table is overall better for SQL. There's other data, for example, like things you might want to store in the database, like I don't know, like when did this customer last update their forecast? When did this customer last download their forecast? When did they last log in to view their forecast? Things like that, right? Things that naturally evolve over time are better for NoSQL, right? Because then you can introduce new keys in there without, like needing to completely write migrations, completely do anything else. That's better for NoSQL. But in the case of when you're storing data that needs to be in a tabular format, and that's really big, and the schema is more enforceable, and it's decided beforehand, SQL is more applicable. You can have another one of these. Oh, sorry. I'm getting worse. Oh yeah, and what's your name? Steven, nice to meet you.
So you mentioned Firebase was cheaper. So what's the impact of how much happened was it itself? How much was it?
So yeah, so the very big so our platform's hosted on Google Cloud, and Cloud SQL is probably like, I don't know the numbers off the top of my head, but like it was a pretty significant cost increase over like Firebase real-time database, which is like, you know, the like NoSQL like built-in thing they give you. But like basically, if we took the, you know, gung-ho route that many, or not many, but like some certain startup founders do, and like, you know, set up Kubernetes clusters is the first thing they ever do, and like before they even have revenue or customers or anything, we would have spent a lot more in our early days. But we chose to, I guess, start off with smaller infra and move to bigger infra, if that makes sense. Yeah, and what's your name? Georgie. Another question?
So was this big increase?
Oh yeah, it's absolutely worth it. So something you have to consider, right, is that our customers are very, are quite non-technical, right? And any speed increase you give them is going to be very worth it, right, to customers. And one big thing to consider is that customer happiness is also really important, right? Like you don't want to lose customers because like that looks really bad on like your company. And if you lose a customer to a competitor, then the competitor can write a case study about you and how like your customer left you, if that makes sense, right? Which like in the eye of the public, you know, could be dangerous.
When you switch databases, I guess you have to teach everyone how to use the new database. You have to allocate time to like getting rid of all the old code. So I guess you have to convince everyone that you should do this. How do you go about doing all that?
So so funny enough, I wasn't the one convincing people. It was more like people convincing me, or like I knew very little, I must say, of like what I just talked to you guys about like 6 months ago. Okay, so basically what we did was we, you know, hired some senior engineers, and they basically looked at our code. They worked in it for a while. They were, you know, they like thought about the problems as a bit as they like, you know, onboarded and worked on the problems and the code, and they were basically realizing, you know, our data is much more, like some of our data, or like most of it, is more suitable for a SQL format, right? And it was very easy, I think, to get everyone on board with this because, you know, people were already familiar with SQL data and like, you know, how the code is written, et cetera, et cetera. And in terms of migrating the all like not just the data, but also the code, I think, well, this problem is special in the sense that like all the data is wiped and recreated every time you like refresh the forecast, right, for a business. So we don't need to migrate the data per se. It's just a matter of rewriting the code. And you know, that was done relatively quickly and smoothly over the course of a couple weeks. And we had, you know, an all-day jam session where we just, you know, cranked a lot of it out. So that was pretty effective, and I was pretty impressed. Good question. I don't think any of you have heard of this problem before. Has anyone heard of this problem before? Raise your hand if you have. No. Okay, that's what I expected. So basically, so I founded this company with my brother, and he went to the other school down the river, and he found out about this problem through one of his classmates' parents, who worked as a consultant for like a big like financial firm that like did like consulting work for some of the CPG companies, and he basically introduced my brother and I to this problem, and you know, we just we initially intended it as like, you know, a like for fun project, but we kind of got connected to a few industry experts in this field through honestly like luck, right? And basically we kind of, you know, convinced them to leave their jobs and do this full time with us. And we got people like Melody who are awesome. Dylan.
You mentioned before that some things are sort of cool. I think that there's for itself, that's sort of that. How do you manage?
That's a good question. So it's, I would say it's like how you manage between different databases is honestly like how well you write your code, right? Like how well you write your API calls, how well, like how well you communicate to your developers, like how to access data, right? Like basically, if you can make accessing data in a database as easy as like writing like one line of code with like as few characters as possible, that is like golden, right? Because like if you can just say like db dot something 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 and then like call what data they want and make it really easy and really like easy to teach and easy to learn, then like no matter how many databases you have, like anyone can just figure out what data is in what database and how to get it, right? If that makes sense. And what's your name? Marcelo. Oh, nope, that was really bad. Oh, that's going to come back to me. All right, I'll just throw it from up here. Oh, okay. Yeah, so it was, it is the, I think, most, you know, I guess, well-established SQL database. And I guess the one that we trusted the most and that our team knew the best. And that's like very important. You need like if you can get a lot of your developers, especially senior ones, more confident about, I guess, like a database or any other system you're choosing, then that's really valuable. Human problems and people buy-in. Yeah. Oh, yeah. And what's your name? Christine. Oh. Any other questions? Oh, I see a Zoom question. Oh, nope, that's just a message.
Explain more about how to do wiping and when like data, like why do you need to store it?
Yeah, so the data that we so like again, this is kind of like out of the scope of what I talked about, but like the data where we source this data from is a different source, right? Like we source the data for like the 50, 50, 50, 100, 100, 100, right? That is sourced from a different part of our database, or like currently a different database entirely. So in our case, we still store that data in Firebase, though, you know, that's probably going to change in a while. But like we can wipe it because like the like it's essentially just computed data from another database, if that makes sense. Yeah, like we don't need to store it. Like we only need to store it because we need to show it in the front end efficiently, right? Like we could technically just compute it every time and show it to the user, but that would be a bad user experience. Good question. We are different because we are actually a venture-backed startup. Our competitors are, like, candidly speaking, kind of outdated, right? Their software still looks like Windows 95, if you've ever seen that before, and doesn't use the latest web frameworks that you guys are learning right now, and honestly, I guess not the best user experience, right? And are kind of, I mean, I don't want to say too many things about this, because I can I'm clearly trying to hold myself back, but yeah. Hopefully that answers your question.
I think one thing that a lot of enterprise applications, ones that are like really big and brand like to do is they kind of trap the customer in with their data. So it's like they make it really hard for you to take your data from one platform to a different competitor. So that's often their strategy. And so I think the way that Cresicor does it differently is by kind of just convincing you to stay because it's a good experience and it does what you need and it has all the right features. And we actually make it really easy to export our data out to other places. So our customers stay because they actually like it, not because they're trapped. So I think that's a pretty big distinction.
Also, what are your names? I don't know, big one, I think.
If you want to get to the last one. Yeah, my name's Eric.
Hi, Eric. We have a couple Zoom questions that do I have time to get to them, or should we? 2 minutes. One question. Okay. Let's see. What inspired you to create a startup to address the problems you mentioned versus working for an established company? Asks Gisela. So I think, I mean, like, that's a question that, is pretty deep, I guess. Well, I guess, like, first of all, right, like, like a lot of you, I've never heard of this problem before, right? Like, I wouldn't say this, creating software for food and beverage companies was ever my reason for being, right? My ikigai, for those of you who know Japanese. But, I think helping people and improving their lives and making things they do 10 times faster, not having the like 40 or 50-year-olds do the my report final fix V2 part 5. I think that is really where my passion lies. And at an established company, right? Like, I've talked to several of my friends who are who've been at bigger companies for several years, and it's pretty much the case. And like, I'm not trying to convince any of you to like join a startup or start one or whatever, or like not join a big company. But it's often the case that people work on very small slices of the company and don't really gain much insight into the bigger problems and the bigger business implications until they've been there for 5 to 10 years. And that's just how it works, right? At a bigger company where you join as employee number 3,000 or 5,000 or 100,000. So I think in this case, right, like it's been a lot easier just being an early employee to see the like bigger implications of the business and everything. And it's been really fun. Cool. Thanks so much to Web Lab for having us. And thank you to everyone for coming out. It's really fun. And we still have a few of these, so please take some.